This is one of the most fascinating stories in mathematics. How a teenage genius solved a 2000-year-old problem with a 17-sided shape. Grab a piece of paper and a pencil because we are about to go on a journey through ancient Greece to 18th century Germany. The ancient Greece. It is the birthplace of democracy, philosophy, and some mind-blending geometry. These guys were obsessed with shapes, but not just any shapes. They wanted perfect shapes drawn with only two tools, a compass and a straight edge. Now you might be thinking, what's the big deal? I used those in my math class. But here is the catch. Their straight edge had no markings, no inches, and even no centimeters. Just a plain old stick for drawing straight lines. And the compass, it could only draw circles. That's it. Let's try a simple construction together. We are going to find the exact middle of a line segment. Don't worry, I'll walk you through it step by step. Draw a line segment. Let's call the ends A and B. Now put your compass point on A and draw a circle that passes through B. Without changing the compass, put the point on B and draw another circle. See where the circles cross. Draw a straight line through those points. And boom! Where this new line crosses your original line segment is the exact middle. Pretty cool, right? But here is the kicker. You have just created a perfect right angle as well. And it is mind-blowing, right? It is just the tip of the iceberg and we are just getting started. Now the Greeks were particularly fond of what we call regular polygons. These are shapes where all sides are the same length and all angles are the same size. Think equilateral triangles, squares, and regular pentagons. Euclid, the father of geometry, figured out how to construct regular polygons with 3, 4, and 5 sides in his famous work Elements. He even discovered a nifty trick. If you can draw a regular polygon, you can draw one with double the sides. So from 3, 4 and 5, you can get 6, 8 and 10 sides, then 12, 16 and 20 and so on. But here is where Euclid and his successors got stuck for 2000 years. Yes, you heard it right. 2000 years. Nobody could figure out how to construct regular polygons with 7, 11 or 13 sides using just a compass and straight edge. Great minds like Archimedes, Apollonius and even Renaissance mathematicians like Descartes tried and failed. It was like the mathematical equivalent of a stubbornly tight jar lid. Here enters Carl Friedrich Gauss. At the ripe old age of 18, Gauss cracked this problem wide open. And he did it with a shape that nobody had even considered before. The regular 17-sided polygon, or as the cool kids call it, the heptadecagon. Now Gauss didn't actually draw the shape. Instead, he proved it could be done. Here is how he thought about it. Imagine a circle. If you could mark a point exactly 1/17th of the way around from the start and then repeats this 17 times, you would have your heptadecagon. The trick was finding this magical 1/17th length. Gauss realized that constructing this length was all about math. Specifically, he found a way to express this length using only addition, subtraction, multiplication, division and square roots. Why these operations? Because they are the only ones you can do with a compass and a straight edge. Now, I know what you are thinking. That formula looks like an alphabet soup and you are right. It's complex, but here is the amazing part. Gauss came up with this as a teenager. It's like solving a Rubik's Cube while also inventing a new color. But Gauss didn't stop there. He figured out a rule for which regular polygons could be constructed this way and which couldn't. This wasn't just about a 17-sided shape. It was about solving a 2000-year-old mystery. Think about that for a second. A problem that stumped the greatest minds for 2 millennia solved by a teenager. It's like if your little sister casually mentioned over breakfast that she had figured out cold fusion. This discovery was so important to Gauss that he wanted a 17-sided shape on his tombstone. Sadly, he didn't get his wish, but there is a monument in his hometown with a 17-pointed star on his back. So why does this all matter? Well, Gauss showed a deep connection between geometry, that is drawing shapes, and algebra, that is working with equations. He revealed that ancient Greek tools of compass and straight edge perfectly match 5 basic math operations. In the end, this story isn't just about math. It is about looking at old problems in new ways. It's about power of young, fresh minds to see that what others have missed. And most of all, it's about the beauty and mystery hidden in the shapes around us. So the next time you are doodling circles or drawing straight lines, remember, you're not just killing time. You're playing with the same tools that challenged the greatest minds for thousands of years. And who knows, maybe you'll be the next one to solve a centuries-old problem. After all, Gauss did it. Why not you? And for Gauss' sake, don't forget to subscribe.